This lesson will focus on L'Hopital's rule. L'Hopital's rule is a way to solve limits that you previously couldn't. There are certain conditions that we will go over in which you can use L'Hopital's rule, but first a general review on what you already know.
Alright. As we've already learned, there's certain ways we can solve limits. For one, we can just do the plug and chug, as Ms. Merck likes to call it, where say you'd have a limit of, as x goes to 0, of x plus 4 over x plus 5, then you can just go 0 plus 4 over 0 plus 5 to get 4/5. A more advanced way you can solve a limit is by factoring it out. So for like this one, you can factor it out to x plus 4 times x minus 3 over x minus 3. These cancel and you get a resultant of 7. In addition to those ways, you can also use a table, a graph. You can rationalize a denominator to also solve a limit. However, what we're going to learn about today is when you get a limit like the last one. Because when you plug and chug for this limit, you end up getting 1 minus 1 over 0, which essentially equals 0 over 0, which you cannot solve with the methods we have already been taught. This is where we come to L'Hopital's rule. So L'Hopital's rule is when you can use L'Hopital's rule in situations when you plug in values and you either get 0 over 0, infinity over infinity, or negative infinity over negative infinity. What it is it's another method to evaluate limits that meet the above conditions. So basically, if you have a limit that is f of x over g of x, then by using L'Hopital's rule, you take the derivative of the numerator over the derivative of the denominator, and to get a new limit, which then you solve for.
Also limit notation in the front. Add that together nicely.
X to a. However, you have to make sure that these limits do meet the criteria. For example, if you were to try to evaluate the first limit, x plus 4 over x plus 5, as the limit approaches 0, then you would get, by L'Hopital's rule, then you get 1 over 1, which equals 1. But as we saw before, that's not the correct answer. When this does come in handy is for limits like the last one. With L'Hopital's rule, this would come up to e to the x over cosine x. So limit x goes to 0. And then e to the x is 1. And cosine of 1 is 1, and this equals 1, so you'll be able to solve this limit.
Here are a few example problems so you get the idea of how these work. We're going to do limit as x approaches 2 of 2 minus x over 16 minus 2x cubed. Now typically how you start a limit problem is you try to plug in the number that you're going towards and see what happens. So this is going to equal 2 minus 2 over 16 minus 2 times 2 to the power of 3. If you solve that out, that's going to equal 0 over 0. This is undefined, therefore we have to use L'Hopital's rule. I'm going to write a note to make sure the reader knows that this is what we're using. L'Hopital's rule is the derivative of the top over the derivative of the bottom of the original equation. So we're going to do that. The derivative of 2 minus x is negative 1 over the derivative of the bottom, which is negative 6x squared. The negatives are going to cancel out, and you're left with 1 over 6x squared. Now note that you actually have to put the limit notation in here, which is something that I always forget, because it's still a limit. We're going to try this process again and plug in 2. Plugging in 2 results in 1 over 6 times 2 squared. When you do that out, that equals 1 over 24. And that's it. Here is another example problem. The limit as x approaches infinity of 3x to the 5th minus x to the 4th plus 16x cubed plus 25 over x squared. Now notice, as we reviewed earlier, or at least I think we did, but I don't think we did, when you approach infinity, you want to look at the dominating term effect. This means that, I'm going to write a note, dominating term effect. This means that as you approach infinity, the only values and the only factors that matter are those with the highest value on the top and bottom. So to show you how that is, instead of talking about it, it's just this piece and this piece, because that's the highest power on the top and the highest power on the bottom. Now note this only works while you're approaching infinity. This is already stuff you should know though. Let's plug in infinity, and you get a big infinity over another infinity. But note that this is approaching infinity faster than that is. So we can infer that it's really infinity over 1, because as you get greater and greater, this is going to get smaller and this is going to get much bigger because it is x to the 5th power. This is infinity over 1. Now note that this problem actually does not use L'Hopital's rule, and you have to watch out for this. This is infinity over 1, not infinity over infinity, 0 over 0, or negative infinity over negative infinity. Therefore, this is the answer, and we do not use L'Hopital's rule. Here is another example. We're going to find the limit as x approaches infinity of ln of x over x. First step is to plug in the value. ln of infinity is infinity, and x is infinity as well, because it's just straight plugging in x. That is infinity over infinity, which is a L'Hopital's scenario. Note that there's no dominating term effect we use, because these are the only two terms in the numerator and denominator. Therefore, when we plug this in, we get a L'Hopital situation. Using L'Hopital's rule, we're going to take the derivative of the top over the derivative of the bottom. The derivative of ln of x is 1 over x over the derivative of x, which is simply 1. So this is what we're looking at. 1 over x, and again, as I always forget, make sure to forget this part. The limit as x approaches infinity. Now let's plug that into x. That's going to equal 1 over infinity. This is your final answer to that problem. We're going to take the limit as x approaches infinity of e to the 3x over x squared. First step is to plug in infinity. This results in infinity over infinity. This qualifies for L'Hopital's rule. I'm going to make a note of that. Now, because now I know I'm not going to forget, we're going to take the limit as x approaches infinity of the derivative of the top over the derivative of the bottom. Derivative of the top is e to the 3x. You need to remember the chain rule. What's the derivative of 3x? That is 3. 3e to the 3x over 2x squared. Just plain 2x. Now we're going to plug in infinity again and see what happens. That's still going to be infinity on the top, as well as the bottom. So this is slightly concerning at first because we ended up with the same thing. Do not give up and continue to do L'Hopital's yet again in the same problem. L'Hopital's, once again, we're going to take the limit as x approaches infinity of the derivative of the top, which is 9e to the 3x over 2, which is the derivative of the bottom. You see how we're knocking off x's here by deriving? That's what we want, because now when you plug this in, you will see how it works. Equals infinity plane. We plug in infinity here, and that's all it is. Bottom becomes insignificant. For fun, let's try one with trigonometry. The limit as x approaches pi of sine of x over sine of 2x. Taking a look at this, we want to start out with step number 1, which is to plug in the value as always. Sine of pi equals 0. Sine of 2 pi also equals 0. This is a L'Hopital situation. Making a note, and proceeding with the limit as x approaches pi of the derivative of the top, that is cosine x, over the derivative of the bottom, that's cosine 2x, but do not forget the chain rule and put a 2 out front. Once you plug in pi here, the top, cosine of pi, that's going to equal -1. Cosine of 2 pi is going to equal 1, and chain rule, multiply by 2. That's going to equal 2. -1/2 is your final answer.